Hey guys, this is Dan, and today I'm going to show you how to hook up an Amazon SQS queue to a Lambda. I'm just going to quickly go over what we're going to talk about today. So the first item is we're just going to quickly talk about this kind of hypothetical credit card transaction application that I've contrived for this example. Secondly, we're going to go over what an SQS queue is, why it's important, why it's useful, why you want to use it. And then third, I'm very quickly going to go over Lambdas, why they're useful, why you want to use them. And I've talked about this in the past, so if you want to check out my previous video, I'll put a link to it up above in a moment. So just quickly going over what this application is and what it's going to kind of represent. So this is kind of a payment processing hypothetical application. So we have a credit card transaction concept where there's people out in the public that are purchasing items, and there's transaction events that are flying through. And so we are going to assume that there's some kind of entity over here. I have it labeled as like a machine here, but it's basically going to be pushing messages into the queue. We're not going to actually hook this part up. We're only going to put messages into the queue manually. So this is going to be kind of simulated. From there, we're going to have a Lambda function that's going to be processing all the events that are coming from this SQS queue. So it's actually going to be polling. That's why the arrow is going in this direction. Going to be talking about polling a little bit more in detail, but basically the idea is that Lambda is going to be trying to get messages from this queue over and over and over again, and that's basically how it processes them. So in this Lambda, I'm just going to basically log the message. I'm not going to be doing much else. This is more of an exercise in how to set this stuff up, not really for implementing your business logic. Yep, so this is my hypothetical application. So now, what is SQS? Why it's useful? Why do you want to use it? So SQS stands for Simple Queuing Service. And what you can basically think about it as if it's a holding pool for messages. Right? So you have events that are coming in. This could be like a web server that's pushing messages into your queue. And this queue is just a holding pool. It's going to hold each of those messages in this queue until someone comes along, in this case a Lambda, that will read messages off the queue, and once it's done processing it, it'll delete the message. So say for instance some application over here comes along, they push 3 messages into the queue. Lambda will pull these 3 messages, process all 3 of them. Could be done all at once, could be done one at a time. Get into that more later. And then once it's complete, all those messages are gone. And they're basically successfully processed. So you can actually have multiple applications here. So say for instance we had like another Lambda that was doing something else that also wanted to listen to these messages. That's not really the intention of this type of like AWS offering here. A queue isn't really meant for multiple different types of applications all listening to the same one. You're looking, if you're trying to solve that kind of use case, you want a message to be sent outwards to multiple applications. You probably want SNS, which stands for Simple Notification Service. And I have another video on how to hook up SNS to Lambda that you can take a look at on my channel. But really, like I said before, it's just a holding pool so that messages can be processed. SQS also has a concept of a FIFO queue, which stands for first in, first out. By default, messages that are sent to the queue aren't guaranteed to actually be available in the order in which they were sent. So say for instance, if you send event 1, this goes into there, event 2, event 3, it's not guaranteed that since you pushed event 1 into this queue that it'll be processed first on the other side. They make a best effort attempt to ensure that it's in order, but it's not a guarantee. That's very important. There's also another concept here called duplication. So it's possible that you will have duplicate events. So say you only push one event, event 1 into this SQS queue. It's possible that that event can actually be present more than once in this queue and could be processed more than once from some kind of listener application. So in that case, you want to have some kind of deduping logic or some kind of like hashing to make sure that you're not duplicating the processing. That being said, that functionality is specific to the default queues, and the FIFO queue does not have that problem. It is exactly once processing. The caveat is that FIFO queues are slightly more expensive. I just checked the cost, and it's for a normal queue, it's 40 cents per 1 million requests, and for a FIFO queue, it's 50 cents. So that's a 20% increase. Personally, for this application, I'm just going to go with the basic queue, but if you want something more reliable, something that guarantees order, FIFO queue is what you want. So very quickly, what is Lambda? Lambda is basically a offering from AWS that allows you to write code and have it executed at a certain point in time without having to actually host it anywhere. It can scale easily up or down if you have hundreds, if not thousands, of concurrent requests all coming in. You can kind of set those scaling limits, and it's kind of an elastic compute engine without having to actually worry about any of the hardware. Okay, so now that you understand what SQS is and what Lambda is and what this application is going to be, let's go ahead and actually make the thing. So I'm going to head over to my AWS account here, and we're actually going to start off by making the queue. You can do this by making the Lambda first, but I decided I just wanted to make the queue first, talk about everything there, and then we'll move on and hook everything up. So I typed in SQS, that brings up simple queue service. We're going to click this guy. And since I don't actually have any queues on this account yet, I have to click Get Started Now. And it just brings you to the default wizard. So this is what I was talking about previously. It gives you, it's asking your name. You can fill this in with whatever you want. And it's asking if you want a standard queue or a FIFO queue. So you have to pick this at the beginning. You can't change a standard queue into a FIFO queue at some point later in the future. And I don't believe you can actually do the opposite. So when you're making this, be sure of what you want, because there's no going back, especially if you're going to hook up other events or other teams to these queues. You definitely don't want to be recreating them every once in a while. So let's just go back to our application here and see what I named this thing. Credit card transaction queue. So I'm going to come back here. I'm going to type in credit card transaction queue. And we are going to use a standard queue here. So if you see, this is basically summarizing what I just told you earlier. Oh, this is one important thing. Yeah, there's no throughput limitations on SQS queues, where FIFO has a 300 transactions per second limit. So that's another consideration here to be aware of. Yeah, so this is the at least once delivery. You have to be aware that there's duplicates that are possible. And like I said before, best effort ordering. So it's not guaranteed. So that's all we basically need to do is to create a queue here. I'm actually going to go to config here because I want to talk a little bit more about these advanced settings. So, okay, so when you click on configure, you get to really specify a lot of the details here, and this is very kind of specific to your application. Normally, the defaults are perfectly fine to leave here, but let's just talk about what each thing is. So the visibility timeouts. So this corresponds to the amount of time a message is basically claimed. So say if we go back to this application here, if there's a message 1 that's ready to be consumed in this queue, and this guy comes along and he says, hey, do you have any messages, SQS? SQS is going to say, yes, I have one message. What it'll basically do is internally it'll issue a lock, and it'll grant that lock to this Lambda. And the lock duration is for 30 seconds. If SQS doesn't hear back in 30 seconds by default, then it will basically release that lock, and this invocation will be abandoned. And that message will then become available for another process or another thread to pick it up. So it's a timeout mechanism is basically what it is. Message retention period. So this is just basically if something fails, how long you want to keep it in your queue. This is especially useful when combining it with DLQ, and I'll get into that in a second. But if something goes wrong and you can't process something, then this is basically the duration in which it's going to stay in your queue. Maximum message size, I don't believe there's any penalty to making this as high as it offers, which is 256 KB. With that in mind, be aware that the message size is going to be enforced on the push into the queue. So if we go back into this architecture, when this kind of client tries to push a message in, if the size of the content exceeds 256 MB, then that's just going to fail. So this guy's going to have to deal with it. And you can kind of set that if you have some kind of use case where you want to restrict size here. Delivery delay. I can't think of many kind of obvious examples in which this is useful, but what it basically is if back to this example, if this guy sends a message into this queue at say time 0, like right now, the delivery delay makes it such that it won't be visible to other pollers until that period of time is hit. So say for instance, if you set your what was the term? Delivery delay, excuse me. If you set your delivery delay to 20 seconds, that means that at time 0, this guy's going to push the message into the queue. 20 seconds later, when this guy pulls the SQS queue, it'll actually be available for processing. Like I said, it's very specific to certain types of applications, but that's basically what this thing does. One thing I wanted to talk about as well was receive message wait time, and this is basically asking you whether or not you want long polling on your queue, and it asks you for a value between 0 and 20 seconds, defaults to 0. So what that means is, in this application, long polling basically means is that when someone asks for a message, like, hey, do you have any messages in your queue? SQS, if it has zero messages in the queue, it won't immediately respond and say, yes, I have 0. Because what would that basically result in? That would result in your Lambda probably calling back immediately after and asking, hey, do you have any more messages? So that translates to a lot of wasted spin cycles, wasted compute operations, wasted invocations, which you have to pay for as a Lambda client. So setting that number to higher, there's actually very little kind of negatives to this, but it'll basically mean that your Lambda will say, hey, do I have any messages? And SQS, even though it has none, will keep that connection alive. It won't respond yet until 20 seconds expire, or if it actually gets a message. So say, for instance, at time 0, this Lambda says, hey, do you have any messages? SQS says no, but it's going to keep that connection alive. It's not going to actually respond no. And it's going to wait for 20 seconds to see if someone pushes the message in. Say at 10 seconds, someone pushes the message in, a transaction happens. That connection, that request will be responded to immediately after that happens. So what this translates to is, like I said, it's lots of saved cycles on this, just pinging it back and forth hundreds if not thousands of times in a for loop with a thread pool. And that means savings for you. So the only downfall of this is that when we talk about Lambda concurrency, because setting this number too high will mean that all your pollers will be eating up concurrency on your queue. So I'd probably be, on your Lambda. So I would probably set this number to 10. Receive message wait time. And I'd encourage you to read a little bit more about long polling and Lambdas, because it does have a cost impact and a performance impact. I'm not going to get into that here, but just something to be aware of. Okay, so dead letter queue. So this is actually kind of important, so I want to spend some time here. By default, this is off. So I've talked about dead letter queues before, and they're very important for like tier 1 production level applications where you can't tolerate failure. So what'll basically happen here is that if you select this to enable a redrive policy, it's going to ask you to say what queue do you want the failures to go into. So what a dead letter queue basically is it's a fallback queue. If, going back to this app, if someone is trying to process a message, say message 1 is in here, if this guy tries to process this message and it fails 3 times, that's the default setting, 3 failures, then this message will basically become invisible in this queue. It'll move to a separate queue. And that separate queue is basically to handle failures. There's nothing that's going to be hooked up to it. It's just going to be kind of sitting on its own. And if you get any failures from Lambda to SQS that are repeated, in this case 3 times, by default those messages will go into this queue over here. And they can basically be processed at a later time. You can set logs, you can set an alarm to page you or email you or tell you when something is going wrong here. It's also great if So that's what that does. So maximum received, that's basically the setting that I was talking about previously. So I said the default was 3. That's typically what I use for these. It's basically saying you're defining here how many times you can fail. So if you say that, if you set that setting to 3, that means that the Lambda can fail up to 3 times. And after the 3rd time, it'll go into that DLQ, which would live over here. Okay, so we're actually not going to use that for this example because it's a whole thing. If you want to use it, you have to create a separate queue and then give the ARN in here. But yeah, I'm not going to do that for this example. Server-side encryption. So if you have like some highly sensitive data, you can use AWS KMS, which stands for Key Master Service. It's basically like a key holder type service where you can encrypt your data with a public key, and the key master service has the private key, and so it can only be decrypted with the private key. I'm not going to be using this for this application. However, it could be useful depending on how you're using this this queue. So after that, just to go back, make sure, yep, I put the name in right, credit card transaction queue. We're going to come down here, and we're basically done with creating the queue. So just really quick, what are we seeing here? So we see the name of the queue, we see the queue type, we see content duplication, which I didn't enable because it's not available unless you're using a FIFO queue. Messages available, which is the number that are available right now to be processed. And messages in flight are basically the ones that are kind of being processed by some other application. So in this case, it'll be our Lambda. There's no messages in here. There's nothing hooked up to it, so nothing will work. And then down here we have all the details. Basically, we just figured out this giant blob here, and then some important stuff. Your ARN. So this keep a hold of this because this is the unique identifier for this specific queue. It's unique to you and your account. And this can be referenced throughout Amazon. So when we go and create our trigger, I'm actually going to copy this to my clipboard here because we're going to need to reference this queue from the Lambda. Okay, so that's actually I wanted to talk about monitoring because this is kind of important from a maintainability standpoint. So from the monitoring side, the only really thing that I think is important or that I monitor actively is your basically your processing rate. So how fast you're processing messages, how fast they're coming into the queue, and how fast they're being processed. And that's represented. It's kind of an kind of an awkward name here, but number of messages deleted. Because basically the way that SQS queues work is that in this case your Lambdas are processing messages, and once they're done processing the message, they'll delete that message. So if you look at number of messages deleted, that's your true indicator of how fast you're actually processing messages from the Lambda side. And this shows like number of messages received. So if your number of messages received exceeds your number of messages deleted, that means your queue is starting to fall behind. So it's starting to get backed up. If you're using Lambda, that should probably never happen because it scales up or down. But if you have some really high throughput queue and a really high throughput Lambda, then this actually may become a problem. Okay. Oh, and they actually just added this other section here, Lambda triggers, just recently. So yeah, so if you had a Lambda that was linked to this queue, it would be visible here. And since we don't have it yet, we haven't even created the Lambda, it's not going to exist. Okay, so that's it for the queue. Let's go over to the Lambda section. So I'm going to come over here, type Lambda. And since I don't have a Lambda for this account yet, you get this kind of wonky UI. Click on Create Function. Okay, so from here we are going to select Use a Blueprint. So I'm just going to be using a blueprint for this exercise just because it sets up a bit of the boilerplate for you. Just makes my life a little bit easier. And in this application, we're going to be using a NodeJS application for our Lambda code. And in order to get that going, in this blueprint section, we type in SQS, and this guy gives us an SQS Lambda polar kind of base application. So I'm going to click on that. And then I'm going to come back to my thing. What did I say I was going to call this? Transaction Processing Lambda. So I'm going to type in transaction process, call it transaction processor. And then execution role. So I kind of got into this into my previous video, but if this Lambda needs some special permissions, like it needs to call DynamoDB or something, you would create a role and give it the permissions to actually kind of access DynamoDB in this case. So I'm not going to really dwell too much on this. So I'm just going to say choose an existing role. Actually, I think, you know what, I think I need to create one because, yeah, it needs special permissions to actually communicate with the SQS. So when you say create a new role with basic permissions, part of the strength of using this blueprint is that it's going to give you a role that has all the SQS permissions. So if you're not sure what those permissions are, what you need, I would encourage you to come and set one of these up, which is kind of like a dummy application. and then checking out the role that it creates, seeing all the permissions that it has, then you can kind of create your own and name it whatever the heck you want. So scrolling down to the SQS section, so basically what's happening here is that Lambda is intelligent enough to know that since we set a SQS blueprint, obviously this app needs a SQS queue as an event source. So it's basically checking our queues to see how many you have. So since I only have one, it's just defaulting to this credit card transaction queue, which you created in the previous step. If you had multiple queues, it'd probably be a drop down here, and then you can select which one you want. So this looks good to me. Yeah, nothing needs to be done here. So batch size. So this is the number of events that or number of messages that you want to read from the queue at once. So there's pros and cons to setting this message kind of low and high. So if you set this message low, basically what's going to happen is that for every message, the Lambda is going to have to go back and ask the queue, hey, can I have a message? And it's only going to get one back. And then it's going to process that. And then it's going to need to wake up again and ask it again, hey, can I have some messages? And then it's only going to get one. So what this basically translates to is a lot of small operations. Very simple one message size operations. If you increase this number to 10 or something even larger like 100, it's going to be fetching 10 or 100 messages at once. So what's that going to translate to you on the Lambda side? It's going to be longer invocation time and larger usage of memory, which, if I can remind you, is going to directly lead to higher cost of your Lambda invocations. In the past, I've used 10 fairly well. I haven't had any major complaints with this. It seems to be kind of a sweet spot, which is why they kind of set it as a default. So I'm just going to leave it as 10. If you want to play with this number, I would encourage you to go up really high, go up low, see what kind of costing you're getting out of it, how efficient your invocations are. But for this exercise, I'm just going to leave this at 10. And then here it's asking us whether or not we want to enable the trigger. I see no reason to not enable this right now, so here we go. Let's just do that. And then the body of the Lambda function. So you can see this is a very straightforward application. It's basically just going to take the events from the queue, and for the contents of the message, it is going to log it, and then it's just going to return successfully. Yeah, and so that's basically all you need to know when creating the Lambda. So now that we've created it, let's just give that a minute to spin up. So while it's doing that, it's actually, okay, so it just succeeded. Oh no, was successfully created, but an error occurred when creating the trigger. Does not have permissions to call, blah, 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 blah. So what it looks like happened there is that the role that I selected by default did not have all the permission sets that I needed. Alright guys, so I figured out what was wrong in that previous step there. So what you actually have to do when you're creating the function is that you need to, when you're selecting the execution role, you need to say create a new role from the AWS policy templates. You can put in whatever role name you have here. So I don't know, SQS role. And then from the policy templates that are provided to you, you actually need to make sure to select SQS, and it's enabled here by default. So just make sure that you do that when you're creating this Lambda, or else you're going to get that error message that we saw on the previous screen. Alright, so after you set everything up, you should be greeted with this message. That is assuming you correct that role problem that I showed you previously. So before we actually go over and talk about and test this thing out and make sure it's working all the way, I just quickly wanted to talk about how the concurrency factor works in here. So if we go down to the Lambda section, we can see there's concurrency. So the way that SQS works, it uses a kind of long polling model. So the long poll basically means that Lambda is going to ask SQS, say, hey, do you have any messages for me? So there's going to be a number of there's going to be a set number of concurrency. Sorry, if we go back to concurrency here. A set number of concurrency that's reserved for basically just asking SQS, hey, do you have any messages? And it's just going to be in a basic for loop. It's going to be constantly asking, hey, do you have any messages? Hey, do you have any messages? Hey, do you have any messages? Over and over and over again. So there's going to be, I would say about like a 10 is probably your starter concurrency for this. So a maximum of 10 Lambda invocations that are dedicated to just this. And so they're just going to be continuously asking, grabbing a message when one becomes available, and then it's going to hand it off to an actual Lambda execution function, which is going to actually invoke your code. So this is all kind of transparent to you. You don't really see any of this. It's just kind of how it works under the hood. So, okay, let's just go back up here. So let's test this thing out, right? So we're going to go back to SQS. We're going to find our topic here. We are going, there should be a way to publish send a message. So I'm just going to send a test message here, 1, 2, 3, 4, 5. And so, so no delivery delay. If you want to set message attributes, you can. This kind of helps the client filter them out in some cases. For us, it doesn't really matter. So I'm going to send that message. And actually, you probably won't even see this number change. Okay, so messages available 1. This Lambda should process these shortly. If not, we may have a problem. You see, it's disabled. I didn't enable it. So let's quickly go back to Lambda. Make sure this thing is actually enabled. And then, sorry. Yeah, there you go. So if you click the trigger on this side, you can see that it's disabled. You need to change that to enabled. So now we're basically online. So if we go back to our queue, we should see that there are 0 available messages. Let's check out what's going on here. Yeah, so there's our message. It's definitely in the queue. It doesn't look like it's being processed. I figured it out, guys. Sorry about that. Don't forget to click save once you enable this thing, or else none of this is going to actually work. So again, I just went back here. I clicked enabled for the trigger, the credit card transaction queue, and then if you click save, that is going to actually enable it. So you see it has a kind of ETA on here. I don't think it's immediate. Basically what is happening under the hood right now is that Lambda is allocating some machine somewhere with this small little snippet of code that we just wrote. It's very basic, just log code, like console log. So it's spinning up a web server somewhere that is underneath this. It's going to be hosting this application. So anytime an event that gets sent to the queue, the Lambda is going to, depending on its volume, it may decide to spin up more instances of the application on separate EC2 machines in order to handle the throughput. That's basically what's happening behind the scenes here. They kind of don't tell you this, but this is just how these things work. Hey guys, so I basically just came back to the SQS section of the console. I'm just back here to verify, okay, there's 0 messages available, and previously it was 1. Must mean something got processed. So if I just expand the monitoring section over here, and yeah, we can see that a few moments ago there was a message that was received and there was a message that was deleted. So this is kind of interesting. Maybe it was a duplicate message here that got sent. That's kind of odd that it was showing as 2. Sometimes these aren't completely accurate, at least in the beginning, so keep that in mind. So let's just go back to the Lambda and verify it on the Lambda side that it actually got processed and emitted the logs. So we're back over here to the transaction processor. Let's scroll down, and yeah, so invocation, so only 1 invocation. Duration was very low, 29 milliseconds, and success rate was 100%, so no errors. So everything seemed to have worked out. And I believe the logs of your recent invocations will eventually show up here. I think there's some kind of delay. Yeah, but if we go back to the CloudWatch section just to check the logs, we can verify that this thing was actually sent correctly. So I just went to CloudWatch. Now I'm going to logs for a transaction processor, log stream, which is basically a slice of your data. And you can see here, here's the 1, 2, 3, 4, 5 that I originally sent. So I was able to process that message on the other side. So going back to the application here, this is kind of our hypothetical thing. So what did we do? We kind of simulated a push from the console into an SQS non-FIFO queue, so just normal queue. We created and hooked up a Lambda using an SQS trigger, and what pushing the messages in basically resulted in this Lambda fetching that message and processing it on its side. and we saw the logs and all the metrics to prove that. So yeah, that basically shows you how to set this thing up from start to finish. If you like this video, feel free to leave comments, like, subscribe. It really means a lot to me. Thanks guys, take care.